In this lesson, we're going to talk about the universal set and the empty set, which are kind of two opposite ends on a spectrum. The universal set is the set of all elements under consideration. So this usually involves some kind of context, and sometimes it's even an assumed context. So for example, consider the set 1, 2, 3, 4. In this case, the universal set could be 1, 2, 3, 4 itself, or it could be all counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on forever, or maybe even all the real numbers. So whenever I say something like 5 is not an element of 1, 2, 3, 4, it doesn't seem strange to you, right? Because 5 is another number, and I'm probably talking about something like counting numbers. However, if I have a friend Joe, and I say Joe is not an element of 1, 2, 3, 4, you think, well, that's really weird and out of context. And that's because we don't want to think of math as like all things in existence, right? So we don't want to have to talk about televisions and light bulbs and people and social movements or something. We want to narrow this down a lot. So we talk about math in some kind of universe, and so we always have some universal set that's everything that we're actually talking about. Common universal sets include things like the natural numbers, which is written with this n, and it's just a set of counting numbers, 1, 2, 3, 4, 5, and so on, and the integers, which is written with this number z, or this number z, letter z. I'm thinking ahead a little bit. It's the German. It's because the German word for number starts with a z, so it gets designated as a z. And it's 0, 1, -1, 2, -2, 3, -3, and so on. So it's basically all just the whole numbers, both positive and negative and 0 included. So number theory often deals with the study of things like natural numbers and integers. Then there's the rational numbers, q, which is a whole over a whole. So there are things that can be written as, like, for example, 2 over 3, but not including things like pi, which has an infinite random decimal expansion. In particular, I say random, but non-repeating is the key there. And then there's the real numbers, which does include all numbers with decimal expansions like pi. They can be infinite decimal expansions that don't necessarily repeat. And you could also think of it as all numbers on a number line. So it doesn't have, well, there's no gaps in a sense. And then there's the complex numbers, which includes the imaginary numbers. So there's the square root of -1, which we could also write as I. Let me move myself out of the way. So I equals the square root of -1, and you have things like a plus ib. So in other words, like you could do 2 plus I times 3. Or you could have things like pi minus √2i or something. All of these would be included in the complex numbers. There's other universal sets, but these are just a few really common examples and some of their notations. So complex is denoted with this fancy C, the real numbers with this fancy R, and the rational numbers with this fancy Q. On the other end of the spectrum is the empty set, and that is the set with no elements. So it's written as a kind of a circle with a slash through it. You could also write it as just a set with nothing in it. So this would be the empty set. But this is not the usual notation. The common notation is to write it as a circle with a slash through it.